In this lesson, we're going to continue on in our section on problem solving part 2, extending unit analysis part 2. So part 2 of part 2. What we're going to do is we're going to extend the use of unit analysis to some problems and answer questions. We are also going to go over metric prefixes and how to use those. So first example, just extending unit analysis. Decide which of the two given prices is better and explain why. Storage locker A rents for $31 per square yard per month. Storage locker B rents for $1.34 per square foot per week. Assume 1 month equals 4 weeks. So in terms of understanding the problem, we've got one option, storage locker A, where our units are in square yard and we're dealing in months, and then storage locker B, which has units of square feet and we're dealing in weeks. So in order to compare these two options, the units need to talk to each other. Right now, the $1.34 looks great, but unfortunately, it doesn't mean anything in comparison to something that's in terms of square yards per month. So you can go either way. You can take storage locker A and make it look like the units for storage locker B, or the other way around. Ultimately, in the end, we should get the same result for which one is better, and the justification would depend on which way you decided to convert your units. So I'm going to convert storage locker B into square yard per month because the way I picture it is per week. I pay it 4 times and I know the price per month. Okay, so I like multiplying rather than dividing. This isn't on here, but 3 feet is equal to 1 yard. So I'm going to start. We have $1.34, and this is in dollars per feet squared. And so remember, I include both of them. They're both being multiplied together to get square feet. And so I need feet to cancel, and I want square yards on the bottom. So yard times yard gives us square yards. 3 feet is 1 yard, 3 feet is 1 yard. So we would take 1.34 times 3 times 3, which would give us $12.06 per square yard. Okay, so now at least in terms of the price per area matches. So we've got $31 per square yard per month, and now we have $12.06 per square yard, but this is still per week because we haven't done anything with this week yet. So the way that I picture it is we have week 1, week 2, week 3, week 4, which is equal to 1 month. And you would take the cost and add it up 4 times. Or multiply by 4. So we would take 12.06 times 4, which is $48.24. This is per square yard. I'm running out of room per month. And so now we're able to compare A and B, storage locker A versus storage locker B. Storage locker A has the better price, and then your justification would go into how you know that using the units. Next, we'll get into metric prefixes. So on the 2 left columns are large values, on the 2 right columns are small values. And so large values, giga is times 10 to the 9th. And recall, this looks a lot like scientific notation, and we'll talk about that more on the next slide. Mega is 10 to the 6th, kilo is 10 to the 3rd, hecto is 10 to the 2nd, deca is 10 to the 1st. Small values, we've got nano, micro, milli, centi, deci. Centi, I think of like a cent is 1/100th of a dollar. 10 to the negative 2nd is denotes 1/100th as well. So how are these used? So let's say we've got our base unit, as I like to think of it, as meter. 1 decameter is 1 times 10 to the 1st meters. It's because we were given 1 to start with, and deca is times 10 to the 1st. So this would be 10 meters. So 1 decameter, oh, I should write in a different color. 1 decameter is 10 meters. 2 decameters would be, this should say 2 times 10 to the 1st. Okay, 2 times 10 to the 1st would be 20 meters. Okay, a centimeter, 1 times 10 to the negative 2nd meters, or 0.01 meters. Okay, remember with scientific notation, if you take 1 meter and then you move the decimal over 2 places, you would end up at the same spot. So that's how these prefixes work with scientific notation. And then if we had 500 centimeters, this is 500 times 10 to the negative 2nd meters. or you could take 500, 1, 2, and this would give us 5 meters. So example, will it float? So let's say you want to put a message of negligible weight and shove it inside a bottle, toss it inside of a body of water and see if it'll float to the other side. How do you know it's going to float? Well, luckily you're in a math class that can help you with that. If the density of the bottle is less than the density of water, it'll float. If the density of the bottle is more than the density of water, it will sink. So suppose you have a bottle that weighs this should say 0.5 pounds. 0.5 pounds, I know that's very different. With a volume of 236.5 cubic centimeters, will it float? So you're given the density of water, which is 1 gram per cubic centimeter, or 1 gram per centimeter cubed, and then we're given that 1 pound is equal to 0.4536 kilograms. So when we're trying to compare our density of the bottle to the density of water, we want to get it into grams per centimeter cubed. We have centimeters cubed, but we need to get from pounds to grams. Your conversion factor here is pounds to kilograms, but remember, you can use your metric prefixes in order to get to grams. Okay, 1 kilogram is 1 times 10 to the third grams, so you can use that as well. So our bottle weighs 0.5 pounds. I fixed it on my notes when I was working this. I guess I didn't fix it on the slides. And we are trying to get pounds to grams. So first I'm going to go pounds to kilograms, kilograms to grams. Okay. And so I need pounds, kilograms. 1 pound is 0.4536. And then kilograms to grams. This is 1 times 10 to the third, or 1,000. Okay, and this is 1 kilogram. So what we would do is we would take 0.5 times 0.4536 times 1,000, which would give us 226.8 grams. Okay, and now in order to calculate the density, we take gram per centimeter cubed. So this would give us 226.8 grams per 236.5 centimeters cubed. If we divide those, we would get 0.9589 grams per centimeter cubed. And so the density of this bottle with message of negligible weight that you don't have to account for is less than the density of water, which means it will in fact float. Thank you for watching. If you have any questions, please feel free to reach out to me.